Okay, hello everyone. I think we can get ready. We have a dual mode audience with, let me see, 7 people in the room and 13 more on Zoom. So welcome everybody. I'm very pleased to introduce visiting Assistant Professor Rosario Esposito, who is presenting our seminar today. Rosario's educational path is quite interesting. He attended University of Siena as an undergraduate and found his way into petrology and love of volcanic processes and fluids. His graduate degrees are dual also, with a doctorate from University of Naples and another from Virginia Tech, where he worked with some of the premier fluid inclusion researchers. Then a period of employment at UCLA, where he facilitated lots of research in the petrology and electron microscopy labs, and began developing a course that we'll hear about in the first part of this talk. So Rosario, welcome. It's a pleasure to have a seminar from you today, and we're looking forward to the material.
Yes, thank you. Thank you. You see, like, we need to have the screen here and there. Does anybody remember how to put the screen? Because right now there is like another user on the screen here.
Well, the camera is there, right? Robin,
Oh, yeah, you are.
in the
Good. Fantastic. Okay, so I want to start this talk just with a prologue. And this is the song. And this is the science. I'm in Colorado, do not fucking add me. I've been on vacation, cause I need you badly. Hotel California, my state. Pulling up in Mexico and New York City, place. Hey, neighbors wanna photo when I visit where I stay. Hey, if you talking drama, get the fuck. Okay, so yeah, the point of this prologue is just make the light on is better because they don't see me. Okay, so the point of this prologue is to basically understand that if you, for any chance, a student that is in the introductory class knows this singer, knows this song, Colorado, from the Coda de Friend, then looking at the videos, you may be more interested to understand about how the mountains are forming, where the singer is actually shooting the video. Is really Colorado. What type of rocks are those rocks shows in this video? And this is the main point of my first part. So the talk, as Christine, thank you for your introduction, actually. And also, I have to say that part of the title is also had some review from yourself, and I thank you a lot. So this presentation is going to be divided into parts. The first part, we are going to focus on the pop culture geology connection. And on the other part, we are going to focus a little bit on my research. To give you like a little bit of taste, how can things be connected in a way, I decided to start with this video.
What's the definition of a pyroclastic flow? That's what happens when a volcano blows. That's what happens when ice cube starts to flow. Red hot lava mixed with saliva, pulverizing everything in its wake. Nothing can survive a pyroclastic flow.
And this is very true.
And no one will survive this this one.
Okay, so basically what I do in my research, I study pyroclastic flow, material that are erupted from volcanoes, and I use this technique, is called the melting fluid inclusion technique. Here we have an example. Actually, we are about at minus 57 degrees using the stage. This is a glass inclusion, so the brown part is the glass. The black part is a vapor. And those are objects that are included in some crystal that are erupted from volcanoes. It is very important today to sort of find the courage and trying to understand a little bit more about diversity, especially in the academic sector or in the STEM part of the work. And as Colorado College, but many other universities are starting now to have like committee about diversity. What can we do to basically make things better? And why we need to make things better? Actually, this is a plot, an histogram that I found on the GSA website, and it shows the ethnicity of the memberships. And you can see that, especially if you look toward like professors or senior or early career, we have a sort of like discrepancy between the percentage of certain ethnic group and what is actually the percentage in the population, okay? And this is important because one of the effort, if we think like about like human beings and our society, how we can progress and how we can find new solution to problems, to natural problems, it comes to so important to widen up as much as possible that spectrum to invite more people, as much as people, no matter what is the background, cultural background, no matter what is the sexual orientation, no matter what is the gender. So the objective, the goal is one. We need to make the society better, and that is our goal. So now I have my mask, and I think we are distant enough that I can take it off, or should I? Yeah. Or we can keep it just, it's just I want to show my face because if you look at me in the camera, now I am on the line, I am what it could be like the typical stereotype of a geologist, white, Western, European, bearded geologist, okay? And this I think is important to say because we need to find, I need to find and ask myself, what can I do to improve that? What can I do to tackle these kind of questions? And the presentation is about that, or I hope it is. With in mind that this is the first time I am trying to understand these kind of problems and presenting about this problem. So there are a lot of people that have done some sort of initiative, and I wanted just to show you. For example, this group of Swedish professor, thank to Christine for this reference, they have done a sort of study where they basically define what is an Hollywood movie, what is a geological movie, and in that definition, basically, they analyzed all the Hollywood movies in which there is, as a main character or not a main character, a geologist. And what is important here is especially this percentage here. Of all the movies that they actually analyzed, only the 11% are geologists that are female. The rest are male. And especially just in one case, the geologist was not a white, or from the white group. So this was so much important problem because, you know, like if you are a kid and you're watching Hollywood movies, that number and this number actually do not show the reality, first of all. And second, it makes even more important to understand how we can actually rise this percentage here. As you can see, this is again like from the GSA membership. We see that there is like a discrepancy again, like between the total member, just 33% are female. Okay. Now things are getting much better if we go to the student. Though it means that for other categories, it goes even worse than 33%. Okay. In other cases, and again, I thank for Christine for the help. This is an initiative that link pop culture to the problem, to make the problem more public, to make people more sensible to this type of issue. And here, in fact, there was like a movie shooted, a documentary shooted by a group of female scientists, geologists actually, paleontologists, biochemistry, where they use this kind of formula to show like the bearded woman as a sort of, again, like to catch the attention and to speak about this problem. There are many other probably initiatives like this, but I want to just to tell you what I have done, I think in a positive way, I hope, in my teaching. So I wanted to tackle especially how can I make like my classroom a more like learning community, a room, a place where all students are feeling comfortable as much as they can to be in class, to be happy, to be not scared about what is their cultural background, okay? And I decided that this question had to be tackled by including pop culture, because pop culture and what you can refer to pop culture is basically what is your cultural background. It can show, it's a sort of mirror. So I had this great opportunity to teach the intro course at UCLA each fall from 2017, 2018, 2020, 2019. Here there are the number of students enrolled, and you can notice that through the time, we went through from like 70 to 100, more than 100 to more than 200. There are a lot of reasons why I can explain this trend. I like to think that the main factor that played a role was actually the introduction of pop culture. So from 2017 to 2019, I have increased systematically the use in class, during lecture, and even like for extra credit assignment, pop culture. Okay, so in particular, in fall 2017, I just used my own cultural background, and just a little bit, I thought about what it could be appealing for the students in the class. And I tried to introduce some concept and probably a lot of lecture using a video, or a video clip of a song, a video clip of a movie, some art, some photography, some TV series, and so on. In the second time I thought, I said, why actually I'm not asking my student what they want to hear about? And so informally, in a kind of informal way, I talked to my student before class started, and at the end, I was always like available 20 minutes or so, even more sometimes, to know them. And I was asking, why don't you write an email with what you like, if you feel about it? And so what I did, I used those songs or those movie clips as a sort of introduction to the class before we started the class. So imagine like you enter in a class and you are listening the music that you like. That was all about. Then I tried to incorporate some of those items to introduce the lecture or some concept, but not in a systematic way. In the last year, I actually did an activity. At the first very minute of the first lecture I was doing for that quarter. And what I asked them is something like to do a sort of like pairing up and ask themselves a connection between pop culture and geology. And in all, and even more than once, lecture, I introduced using those items. So, more specifically, again, like I pair up people and I ask them to introduce, and then I ask them to do to find something in common that could relate to geology. And then, after some minutes, I told them that I was setting up an anonymous feedback web page where they could actually insert their pop culture preferences without being known. So this was like done in order to incentivize them to insert something about their cultural background that they maybe not feel comfortable to share it to you directly. So I was wondering, and then I asked them to do it like even like in progress during all the course. So if something was coming on, they could actually fill up and continue listing the items. So why don't we do here like a sort of similar exercise? What do you think? So in the room, we can do, you can write on a piece of paper, or you can like email me after, or just tell me by voice. For the Zoomer, right there, we can actually, you can actually write things on the chat. And you can do it not just in this first minute of presentation, but you can do it like toward all the slides that I'm doing if something pops up in your mind. What do you think? Yes? I'll give you 30 seconds to do this. And at the end, what we can do, what it could be cool to do is actually make a list of songs and movies or other type of pop culture items, references in our website on the department or in our Facebook page. What do you think? Okay. So, and this can be like anonymous. So you're gonna see the list. And potentially what I actually had done, and I'll show you a slide about it, I have made, especially for the song, a playlist so that we could use like during field trip. And it was a total fun and a total success, I would say. I don't know. Anyway, yeah, I'm gonna just show like and give you some example of what I mean by connection of pop culture. And again, like I don't mean like necessarily the strict movie or song about geologists where there is a rule of geology where we talk expressively and directly about the geological problem. It's more like much more wider. In this case, actually, the connection was pretty tight. And I found amazing the fact, for example, that when we talk about plate tectonics, usually it's at the beginning of an intro course in earth science. And, you know, like I was always impressed to know that the majority of the students really didn't know anything about Mary Tart, where indeed they knew like Alfred Wegener. But at the end, I mean, she's the mother of plate tectonics because if she would never like intuitively saying that there was like a reef valley in the middle of the ocean, then we could not actually be at this point, probably much later. So and there is this song about Mary Tart, about a group of rapper singer. They are called the Amoeba Group. And I want to just give you a little taste of this.
In the early 1950s, Marie Tharp's ideas were dismissed as girl talk. Last name Tharp, first name Marie, with an expertise in cartography. Got a job mapping the ocean floor, using sonar data from the Second World War. But she needed new data to complete the map, so they loaded up a research vessel ASAP. They sailed out of the sea, but they didn't bring along the rain. They didn't let women on the research vessel, so with map-making tools, Marie did nothing. She showed it to a colleague, Bruce. He said, Marie, and around Marie's Shanghai's love commotion. And she said there was a red valley at the bottom of the ocean. Girl talk. That's what the man said. Yeah, that's what the man said. He called it girl talk. Rejected like that, and 2 seconds later, he called it girl talk. A valley with a red pie, continental drift. There ain't no place in science for no slow reliance on the girl talk.
And I was, yes, exactly. That's what I want. And I told my students,
Marie went back to the drawing board. Literally, she had a drawing board. She checked it once and she checked it twice. To be triple sure, she checked it thrice. She took it back and she showed it to Bruce. But this time, he called the truth. He shook his head. He said, Marie, I think I owe you an apology. Your map is right, yes, I must admit, but I'm worthy.
And we can stop here. But, you know, like, I was happy to see like somebody moving. And that's actually exactly what I wanted from my student. I mean, like, we forget that we are gifted. We have such a privilege to be sitting in a room and learning about something like about, you know, science, about something that it can, you know, increase your culture and make your spirit up. And there are a lot of studies, and I am missing a lot of reference in this talk, and I promise I'll do much better next time, that emotions are so tightly linked with what you learn, with the information that you retain in your brain depends on the type of emotions. And so, for example, I always think about this about me. When I was 5 years old, I was doing this long immigration travel. And if there are some Italians on the audience, they will understand like what it means to go from Naples to Florence to Siena with a Ritmo, or it's a very like bad car, Fiat car. But those trips for me were like so exciting. And during this trip, my dad and my mom used to put on a sort of song. And I can tell you that you cannot find on internet that song, but I still remember most of the sentences of the lyrics of that. Because for me, that experience was fantastic. And it makes a lot of sense to me when we talk about correlation between learning, retaining information, and the emotional state that you bring in the room. So this is another example, and I knew that I was getting excited. We are running out of time for sure, so I'm going to apologize at the beginning. You can shut me off whenever you want. Okay, but this is another one. This is another video that I actually used to introduce the weathering of igneous rocks, but not only this. Okay, so the free solo documentary actually was a winner for the best documentary, and it is fantastic to see that the directors, especially one, I don't know about the other, they are actually climber too, okay? And it would be too much surprise to some of you if I tell you that some of PhDs in geology are actually based on climbing, the El Capitan in this case in the Yosemite, and mapping the things. But there have been like friends that I know that are good climbers and geologists that actually were hired by biologists to go like and climbing cliffs to get eggs or photographs of birds. Huh? That's what to say, because I bring it up because it is important to understand, I believe, in an intro earth science course, that the skills that you develop in many other type of environment or topics or I don't know. So whatever you do with passion, whatever you put inside yourself, you may gonna use it for other purposes. In this case, a PhD. The same is for the director. He's using his skills as a climber to filming. So you see how many things are connected. So one thing that you do in one topic, it may be very useful. One experience that you have in life can be very useful for another total different experience. Okay, so this is how I introduce actually my metamorphic lecture. This is exactly the slide that I used in my class. And there is some nudity in this slide. But I started the class saying, this is, do you know what it is this? And somebody would say, oh, this is the Michelangelo's David. Okay, good, perfect. Do you know what rock is the Statue? Somebody would say, oh, no, okay. Then we'll come to marble. And then I would ask, why do you think Michelangelo was actually using this rock and not another to make his beautiful statue? And there start the discussion about how you can regrow and transform crystal, and how you go from like a limestone to a marble and so on. This is actually another slide that I used, and this is another connection. It's about Call Me By Your Name. It was actually nominated for the Oscar and won the Best Adapted Screenplay. It's by an Italian director, and it's about an homosexual relationship between two men. And I used this. This was actually from the reference list that my student gave me. And I use it because, well, first of all, because the music is extraordinary. But also because they are in Italy, they are in the mountain in Lombardy, and they go for a field trip, and you can see like the geomorphology, the cascade, so there is hydrology. You can see like the rock bendings and folding in the mountain. And all of these, I mean, like you can use it to introduce all these type of things, okay? So again, with the thought that if you can relate to that, if a student can relate to that, especially if it is from a minority, you will have more chances to be interested in what I'm saying after. Okay? And you can see how it's beautiful here. I think the cascade of Serio, or Sorio, I don't remember. But you can see a certain point of the cascade, and you can see the bending and folding of layers. Probably the quality of the video is not that we can appreciate. You see, like you start to see the mountains, and then you can appreciate the sort of like folding inside the rocks. And I found all of these romantic in a scientific point of view. And as I was trying to say and make my point before about emotions and learning, a lot of songs that are related to geology, they relate to geological catastrophes. Because I believe, and this is my interpretation, that there is nothing like more powerful or catastrophic than the natural catastrophe itself. So it's the best analogy that you can use when your heart is breaking, when something goes wrong in your life and you write a song. A good analogy is the geological catastrophe because it gives you right away the idea. It is important, like this song, I don't know if in the audience you know, Landslide, it has been like actually covered by many other rock bands in the US. And it's beautiful because if you read the lyric, and at least like my impression, my interpretation, is that there is a sort of like, not just the landslide, but there is also the element of time and change. So how you can see your life at different stage of your life. And it is, in particular, is important to me because I mean, 4 years ago, I became a father. And so time and change in geology has a certain specific meaning. And we can use that. And I want to just show you like a little clip because, you know, those are the things that I wanted to say. If you don't, and I was like saying before the talk to some of you, if you want to relate to your student, you need to ask them and you need to have their preferences. Because even though I actually knew the artist before the lecture, I didn't know the song about this artist. And this is like a 2019 song. So if you don't really are keeping pace, you can not. So if you want to relate to your student, you need to know what is fashionable for them, what they like. And you cannot guess it. You just need to ask. And even though like the singer, I have to say, has been like sometimes criticized for misogynism at a certain point, I think his art is exceptional. Yeah. And in this case, the song is Earthquake. And it is funny, like how in these video clips, if you go toward the end, let's say here, so earthquake is not my fault. Fault causes the earthquake. And the funny thing is that now the stage is getting on fire. And fire is an hazard that is connected to earthquake. So actually I use this as a sort of one of the questions in the final was about what is in the song of this scene, the main hazard caused by earthquake. Okay. So, and again, like, it's very important to say this, you know, I don't know if you haven't know this, if you know this psychologist, is Daniel Goleman. It ended up that he wrote this beautiful book that I devoured, like those are like 500 pages. And it was a particular time in my life. It was in 2007, there was the Virginia Tech shooting. So this is another, sorry. This is another song that I used to introduce a certain type of topics. And actually I use it in a sort of very interpretative way, because you can certainly use this video with certain type of background message, but I care more about the science. So there are some scenes, as you can see in these, in which you see New Orleans or flooded. So you can talk about floodings, you can talk about climate change. But the main reason why I use this video is because the song is actually a sort of incitement, incipit, to say to the younger generation, look, I mean, like you have to work hard, you have to build your credential if you want to write a certain type of goal in your life. And this, to me, links with the science communication. And what happened, like in the L'Aquila earthquake, where there were like a group of geologists that was like sued for manslaughter. And I believe at the end, without taking any political direction here, that if you are a scientist, you need to know how to communicate. And if you want to know how to communicate, you need to have your credential, because if you don't have your credential, you cannot be listened. Or if you are listened, you can totally be, you can create damage to the society. And we can see, actually, there are some scenes here again, like probably the most famous of Beyoncé, that was it was like, there is this portrait of her being like sitting on a police car with the flooding on, so with the arms like that. A lot of meanings in a sort of civil right direction, but also on geology. Now, I wanted to conclude with the connection with this, because I think it's the best connection ever. Is sometimes when you are listening things based on what your students are saying, and then you are checking. And I think Greta, you can use like, her interviews, her demonstrations, her appearance on the media to talk about climate change. I actually think that what she's saying, especially in this interview, it encloses all the intelligence of the science of the world, because it's basic and it's so important during this time. And she's so right, okay? And I want to just play this for you. So not all the video, but okay, let me see because I cannot see the time here.
I have Asperger's
Yeah, you are.
in the autism spectrum, so I don't really care about social codes that way.
In fact, you called your Asperger's, you called it a superpower, a gift. What do you mean by that?
Yes, in some circumstances, it can definitely be an advantage to have some kind of neurotypical diagnosis and to be neurodiverse.
Here.
And because that makes you different, that makes you think differently, and especially in such a big crisis like this, when we need to think outside the box, we need to think outside our current system, that we need people who think outside the box and who aren't like everyone else. And
this began as.
And I think with that answer, in one sentence, in a few sentences, it's actually enclosed all what we are trying to do now in various universities. So if you want to solve problems, you need people that think differently. So I mean, like, you need people that knows really well what he's talking about. But we need also those other people that, knowing all the things, they manage to break the rules, and they may manage to make other rules. That's how we progress, I believe. Okay, so a year back in my class, what I did an extra credit assignment for the students, where I asked them like to select a video and say, why do you think the instructor showed this video to you? Again, like remarking, trying to fix certain type of knowledge that may be related to what you choose. And then basically understanding and asking them like to develop a little bit of critical thinking about why do you think, why basically, how that changed the view of your world. This is the song playlist that actually was coming from the reference from the students. And you see like the crosses are indicating that more than one people have actually selected the song. And this is the field trip I did last year. So this is very speculative at this stage, but again, it's a starting point. And like my former supervisor, Bob Bonner, used to say, you need to put the duck on the shelf so that you can shoot it. So basically here from this diagram, you have the grade and the percentage of that specific grade. And then you have like the different tiers from 2017, 2018, 2019. Okay, so you basically go with time on one direction. And even though like for B and C's, there is no correlation at all, you actually see that with the increasing use of pop culture, you have that the A's are going up. Huh? And most important, the D and the F are going down. Okay, so now there may be other factors that plays on that, even like subconsciously biased by what I'm doing, even though like I'm looking this in retro view. Okay, but anyway, it would be like interesting to see in intro courses, even from other majors or other departments, if that kind of exercise, that kind of inclusion could actually improve the grades of students, the performance of students. Last summer, since we had like this unexpected time, I did the online version of this class where there were much less people. And I wanted to go like a step forward. I replaced the lab that we were not able to do it with a project that was connecting geology to pop culture. And there have been like people that have connected Daniel Caesar, the song Entropy, to the entropy of magmas. This is like the Matterhorn bobsled from Disneyland. This is the Earth song by Michael Jackson, John Denver, Colorado Rocky Mountain High. And let's stop on the Pink Panther movie, okay? So I want to show you this clip here. This is the first scene of the Pink Panther. Oh, the Pink Panther. And then the song goes, da-dun, 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 da-dun. But anyway, this is fiction. However, the diamonds, and like they say that the Pink Panther symbol was there because there was like a flaw, a discoloration. And this discoloration, in a scientific sort of interpretation, could be like due to inclusions that are inside the diamond. And those are actually real. And if you think about gemstone, the inclusions, fluid and mineral inclusions that are inside the diamonds or gemstone in general, they can be authenticated just on the inclusions, because you can make those objects in the lab, but what you cannot reproduce in the lab are the patterns and the type of inclusion that are inside the diamonds, okay? And from the scientific view, it's amazing how basically we use, diamonds and fluid inclusion, especially in diamonds, are representing the deepest direct evidence of what is below the earth, very deep, even like at 400 kilometers, okay? So an understanding about these objects, it's important because we understand then like what is the deep cycles of volatile like H2O and CO2. And what I do in my research, I actually study this sort of similar objects, so inclusions that are not in diamond, rather are in crystals like choline and probably like people that are not from Georgia are gonna lose me here. But anyway, I am studying those inclusions that are from crystal erupted from volcanoes. And this is important, and my focus is actually on the volatiles like H2 and CO2, because those are, again, like have implications for the climate change, for the global climate change, but also like for the magnitudes of eruptions, for the formation of our deposits, for how magmas are moving to the crust, and so on. So, and why I study those objects? Because you can certainly put an instrument on the vent of an active volcano and getting like a composition of the gases in order to like forecasting eruptions. But what you see here is never like 100% the magmatic volatiles. So by magmatic volatiles here, I mean those volatiles that are directly exsolving from the magma at various depth on the plumbing system. So below the volcano, you have all these pools of magmas, and we need to understand what's going on there. The only way to tackle these questions is to study melt inclusions, like I was telling you before, because the host, like in this case, olivine that is outside the melt and the vapor, it prevents, partially or in a sort of way, the exchange between what is inside the crystal and what is going to happen after. Okay, so it's a snapshot in time. Eh? How do they form, those melting inclusions? Those melting inclusions are forming because nature is not perfect and crystals are not perfect too. And the way that they will grow like in a different way depending on which direction you're taking. Eh? This will leave like some sort of gaps, and for the crystal then is energetically much more advantageous to just close with bridges and go on with crystallization. And here you have actually a natural picture from the electron microscope. And you will see like how in the center of the face of this mineral, you have gaps that may be like further enclosed, bridged, and then you will form a melting inclusion. And here is actually an example on how we can reproduce the same in the lab. When you do this kind of cross connection, you're sure of what you're talking about, talking about connections. This is another example how they can grow the melting inclusion, how can be trapped. Those are crystals from the White Island volcano in New Zealand, infamous because in 2019 actually killed 12 tourists. And the way that those inclusions are trapped is because inside the magma chamber, sometimes things are happening very fast, and the crystal either has to grow fast or to dissolve fast. And so it will create a sort of like rough surface for which further the crystallization and development may enclose those kind of melting inclusions. So what I did, this is like at the beginning of my PhD. I study volcanoes, sun system all around the world. In this case, in Italy, I started from there. And it is Campi Flegrei, it's the sister of Vesuvius that is much more famous for the Pompeian eruption. But it's actually, at this time, much more dangerous. And here are layers, and here is the woman that turns to be the mother of my son. And I would actually go there and get samples. And then you go on the binocular and you're selecting crystals. You give them a little bath, they are gonna be clean now, and then you work on them. And when you think about this process, a lot of people linking with the free solo documentary. Skills that you're using in one discipline, in this case like a PhD, can be used for many other purposes. And I think that polishing a crystal, it is actually an art. It takes time, it takes creativity, it takes passion, and it takes practical skills and perseverance. So most of the time on my PhD actually went on working with my hands as I would be like a jeweler, cutting diamonds. So eventually you section this kind of crystal and then you study those objects again. Those are the melting inclusion with vapor bubbles and so on. And why you do this, in this case, just part of the research was to analyze the volatile content in the bubble and in the glass in order to understand what is the volatile content of the magmas. And with that information, you can make those kind of diagrams, H2O 8%, CO2 ppm, and you can see how the concentration of those volatiles actually change with the time that those samples were erupted. And eventually, you can see that there is a sort of correlation, where you go from high to low maximum CO2 value. And you basically can make the point that at a certain point, from early to late time, the CO2 maximum was dropping. So you can say that initially, the crystals that were erupted were covering this much depth, in this case, 8 kilometers. Then, as the eruption progressed, only crystals from 6 kilometers were erupted. And toward the end, as the volcanic activity loses power and momentum, you have crystal just from 4 kilometers. So again, you can see the melting inclusion as a little volcano, with some difference, of course. But we have everything. In a magma chamber, you have melt, you have crystals. In a melting inclusion, you have crystal around, you have melt, now glass. What is different is that the volatile that is forming here. So the bubbles of H2O and CO2 that are forming here are actually escaping the time. With the melting inclusion, they remain there. So they can be studied. And again, with all the implications that I was trying to mention before. So again, like there is a difference in time when you talk about what these represent and what these represent. And it's important to take this in mind. So in the next slides, what I'm going to talk about is the last part, and I think is the more exciting. When I was at a certain point in Australia working with Crystal in the Leonid Danijescu's lab in Tasmania, Nobel, I came with a sort of intuition. Because whenever you analyze these bubbles and whatever has been published in the literature, you find CO2, but you never find H2O. That actually, in some cases, should be the only one that you should find it. Nobody would actually always assume the presence of it, but never gave a direct evidence, especially in these objects. We tried to publish this in Nature, we didn't manage. The intuition was this: let's try to reverse the process that Mother Nature gave us, okay? So Mother Nature was trapping the melt in a crystal, and then with temperature going down, and we are like here at 1200 degrees more or less. Then you cool the temperature of the magma chamber, and then the melting inclusion is crystallizing, so it's becoming a mess. The water that is actually here on the edge, on the boundary between the vapor and the melt, and the glass, when it erupts, it reacts with the glass. And we know, with some sort of basic in chemistry and geochemistry, that water is very rapid to react with the glass. So if you are not getting that in time, you're not going to measure it. So I say, why I'm not going to do the same? I'm going to go in the lab, go up in the temperature, form a bubble, and quench it. And now I have my baby bubble, fresh bubble. I'm going to see if I found water. And just 2 hours before I was leaving the Blacksburg lab to do Raman spectroscopy, I had this eureka moment in which I felt so happy and extraordinarily lucky to have done all this work. So I found in this fresh formed bubble the CO2 spectrum, common. Not that common, negative sulfur plus calcite. And it makes a lot of sense because when you go to to volcanoes, you smell like rotten eggs, sulfur. And then moving my spot right at the boundary as taking the reference of this, boom, the liquid H2O. The liquid H2O is there. It is a mistake or maybe not. So I said, maybe, I'm not looking right because there is actually a peak that comes from the water in the glass, the solvent in the glass, but the peak is actually different, so it could not be. Wow, so getting everything back together, this was the model. Okay, so the water is still there. If we do analyze it very quickly, then it's there. I want to conclude this presentation this way. I found that amazing, that you find the H2O there. And then it happened that was so lucky that I actually met this person that is a conceptual art artist. His name is David Horwitz. He has also a Wikipedia page. He does a lot of art. And you probably know his art even though you don't know him. And he had this neon art where he said, whenever I take a shower, I always wonder when the water was a cloud. When I read that, and I was actually talking to him, I said, that is not possible. Is the same for me? Before I read that, actually, when I was taking a shower, maybe some days before I was talking to this guy, I was thinking about the water, not just when it was a cloud. So I take a shower, whenever I take a shower, it's actually an exaggeration, not always. I always wonder when the water was inside the earth, then in the cloud, then in the ocean, then in the sediment of the ocean, then dragged at a great depth in the subduction zone, then transported in the upper mantle, then joining a molten rock, then causing a volcanic eruption, And now back in the cloud. And I found that so poetic. I literally fell in love with my shower. And as like my favorite artist and singer, the Italian singer said, you can find poetry everywhere. And that's, I think, all the point of this presentation. So I want to thank you. And I will take questions. I will take email after everything. And thank you again for the opportunity. So I don't know if we should how we should proceed. There is actually time for questions or not?
Well, I don't know the time piece, but I think there's always a good reason to celebrate questions. Robin, do you want to go to
Let's do
the
this.
computer and just read the chat and the live Zoom one there? You can probably turn it at this point so you can see it. And then Rosario, if you just want to invite people who are on Zoom to ask any questions either out loud and in the chat, and Robin can email them. Or Robin, do you want to invite that?
Actually, I'm gonna put the camera on if you don't mind.
That's the camera.
Okay. Okay, so thank you for the people that are there.
The camera's on, and if you look at the camera,
Yeah.
they will see you.
So if you have questions from there, I will take questions from there. Maybe they are not muted.
I have a question.
That's good.
I have a question.
Wow, beautiful. No, there is no writing. Okay,
I have a question.
I think somebody. No. I think people are starting disconnecting.
So any questions from the floor?
When you're teaching introductory geology using your pop culture, how do you not keep getting distracted from actual geology? Or is that the point?
No, Steve is your name.
Yeah.
He's actually, let me go on the camera. So I'm going to repeat the question. So the question, if I am getting right, is how do you know that people is not getting distracted from the science type of course of the lecture? And I'm going to answer this way. There is certainly a risk that this is happening. And there is certainly coming from those people, from those students that are actually already know that they want to be a geologist. So, I was not one of those students. And, but there were students in my year that were these ways. They really knew and they really were focused on that. So here the point is to get those people involved that are not initially excited about it. So you need that kind of step. Okay. Now, when I actually decided to come here at Colorado College, I had like a sort of idea of what was the block system. And one of the reasons why I wanted to be here, it is because of this, because you need time. So if you have time, if you have enough time, you don't have to be worried. So in here, like you have a day, so you can, if you want, get people in because you can create your own activities as much as you want. You have all day available. So, but again, like, choose between being in a class, listening, and not be excited about it. And this is happening a lot. It happened to me. You cannot be interested in everything. And being in a class in which, okay, I go there, at least, I can sort of try to find, myself on it. And I think that the main problem for this category of students, like it was for me, is that you need some sort of incentive. at a certain age, you can be easily discouraged about things, especially if you are from a certain background. There are these imposter syndrome. I was totally affected by it. My father was a school cleaner, my mother housewife, my sister with disability 100%, low income family. Thinking about first generation graduate, thinking about being now here, it was no way. No way, I'm gonna try to do my best to finish the thing and get into work somewhere. Maybe it would have been better. But, students need to be encouraged. They need to know that they can do it. I think when I think, especially now in this time, about new generation, they need to be, our job is to incentivize them. So get them in the bus, get them believe that they can do something, they can become something. And I believe that if you are not doing some work in order to bring them in the bus, Professor, was just saying and testing us on memories and things. Okay, we can do that. I'm not saying that, but I think that there is a category of people, a good percentage, and if you don't do that, you may risk to lose them. What I actually, it's such an important question, Steve, because, I have to be honest, you are definitely right. I mean, I had evaluations from my students saying, the professor is showing useless, unrelated videos in class. And I am a geochemistry major, already know what I want to do in my life. I really don't care what I was doing, lost all time. And I said, okay, this is a possibility. I have to acknowledge that. So I was thinking inside me, next time, what I'm going to do, I'm going to see who already knows that wants to be a geologist. And then I'm going to try to invite them to make some sort of more projects geology oriented so that they can find themselves too in the class. Because you are discriminating in the other way. Okay, so there is always this risk, but it's a choice and is experimental. So, and I think that, I found myself in this position in which the excitement of teaching is to learn how to teach. And the excitement of learning how to teach is about experimenting, not finding yourself always on the same spot, but challenging yourself. How can I make these things better? If I don't change anything, we stay the way that we stay. But we are all doing this discussion about it's not good where we are. So why we should stay where we stay? So we need to experiment. And I found this exciting, with the risk of losing something, always. I think I can talk like infinitely up to more. So.
Yeah, probably, we do have some students who have gone for the class
Yes.
this afternoon, so we should probably conclude. Let's just thank Rosario again.
Thank you. Thank you. It was beautiful to have you here so that I could relate to somebody.
Yeah. Oh, yeah. That is beautiful.
Should I stop recording?
Yes.
Wow.